So I guess I can only talk about compute. But here's what I observed, and this is what I thought, because I'm in the market for building compute and sourcing compute for customer. I have thought after billions of dollars spent, we will have enough compute. There are enough compute for a certain cluster size. But now with the new wave of RL on all kinds of things, people are doing training again with inference. That's what RL does. And so the need for a large scale, 1,000 size, GPU size cluster basically does not exist in the market right now. And so for folks here, if you are doing some training or want to do some sort of RL, I would suggest to source them as soon as possible. Give yourself at least a 3-month lead time. This is for most useful for audience. And then if you're looking for compute, you should look for a cluster that has done pre-training, because these compute is not as commodity as people thought. People think of it as a flop. But these are highly delicate machines and are very hard to maintain, especially at a large scale. The difficulty increases exponentially once you connect thousands of them. Even one node fails, you reset your entire training. So the only methods that we have now really is setting a lot of checkpointing. So right now, I think what's lacking is not general compute, but a scaled size compute infrastructure. And that is one part. The second part is will be limited to smaller group of folks, which are what is beyond, say, 1,000 or 10,000 cards. Those bottleneck now, I'm sure you probably see headlines, are power. And doesn't have enough available power in the US, around the world, to power these supersized cluster. So right now, I thought I got into this market so I can build software and build kind of hardware and software infrastructure for folks, right? Optimizing workflows and so forth. But now, interestingly, majority of my time is on sourcing power and finding creative way to generate power myself. For example, I'm discussing on using a hydrogen-based data center and then having a kind of byproducts water and use that to chill the entire servers. And so it's a single loop. It doesn't consume any excess water. And then we basically have a closed loop system. And you can basically scale that infrastructure to gigawatt size for companies like Meta or Google and so forth. So this is the next challenge that I'm facing, is back to actual physics on how do I find enough land, how do I have enough power, how do I have enough cooling systems and heat problems, and scaling a gigawatt size data center for hyperscaler customers.